Let's begin our look here at parallel circuits. So parallel circuits are when there are multiple paths or branches for the current to follow. So let's say the electricity comes out of this red wire here. It could go through this middle light bulb and back to the batteries, or it could go through this outer light bulb and back to the batteries. Here's a circuit schematic showing the same thing. Two cells create our battery. We leave the positive side, we pretend. You could go through the inner bulb and back, or you could go through the outer bulb and back to the circuit there. So there's going to be a series of rules, 4 great rules for series or parallel circuits, just like there were 5 great rules for series circuits. So let's begin with an analogy right here. Let's say you've all been to a water park where there are more than one slide to take down to the bottom. So let's say everyone starts up here, and let's just pretend for now everyone's got about the same mass. So everyone would have the same potential energy up here, no matter which slide you eventually took down to the bottom. And all the slides end down here, so everyone would have the same potential energy when they got to the bottom here. And so here's the thing, same potential energy at the start up here, same potential energy down here at the bottom. So there's the same change, there's the same drop in potential energy for everyone as they go down these water slides. We say then that there's the same potential difference. And so that translates to the first great rule of parallel circuits. Each branch drops from the battery's positive terminal to the negative terminal. So the voltage drop is just equal to the voltage of the battery. We could say it in an equation form like this. The voltage of the battery would be equal to the voltage across resistor 1. That would be the same as across resistor 2. And if there was a third one, across resistor 3, and so on and so on and so on. So let's say we had this circuit right here. A couple of cells gives us a battery, and we got a resistor 1 and resistor 2 and a resistor 3. Let's say it's a 9-volt battery. Well, since it's a parallel circuit, and again, it's like the water slide. Here's the top of the water slide, and there's 3 choices of slides to get down to the bottom, but it doesn't matter. They're all a drop of 9 volts because they all start on this end of the battery and they all end on this end of the battery. It'd be like if it was a 9-story water slide and there was 3 slides at the top. Each slide, since it starts at the top and ends at the bottom, each one would have to be a 9-story drop there. So that's the first rule. And again, you'd start up at 9 stories here and end up at 0 stories there, so they all drop 9 volts. The second great rule of parallel circuits is that the current will divide into the different branches. And we can use Ohm's law to figure out how much current goes into each branch. So for example, if we wanted to figure out the current in branch 1, we would take the voltage, which is the voltage of the battery, and divide it by resistor 1 to figure out how much current goes into that branch. So let's look at this example right here. We have a 24-volt battery connected in a parallel circuit with 4 different resistors, a 10 ohm, a 20 ohm, a 30 ohm, and a 40 ohm resistor. We can use Ohm's law to figure out how much current goes into each. So for example, the current in branch 1 would be the voltage divided by resistor 1. The voltage we're talking about is the voltage of the battery, because every resistor in a parallel circuit is simply the voltage of the battery. So 24 volts divided by 10 ohms for resistor 1 will give us 2.4 amps. So 2.4 amps flows through that branch right there. We could repeat this for branch 2 and resistor 2. So voltage divided by resistor 2, so 24 volts divided by 20 ohms would give us 1.2 amps. Repeat this for resistor 3. So 24 volts divided by 30 ohms would give us 0.8 amps. And then we could repeat this for resistor 4. So 24 volts divided by 40 ohms would give us 0.6 amps. So 2.4 amps through here, 1.2 amps through here, 0.8 amps through here, and 0.6 amps through there. In the second video, we will look at what happens after this. So what happens when all these currents combine.